Hello and welcome to our STEAM project number 7, based on the Raspberry Pi Pico and MicroPython. These lessons are designed for the somewhat experienced STEAM teacher. We call this intermediate level the Sherpa level. In this lesson, we are going to build a Ferris wheel based on a stepper motor and control the direction of the wheel with a joystick. My name is Peter, I am the founder of Educomondo and a certified STEM instructor and course developer. The goal of today is to read the analog signal from a joystick to make a stepper motor go slowly either in clockwise or counterclockwise direction. In detail, we will look into the working of a joystick. We will learn some additional MicroPython code. We rehearse the working and the operation of a stepper motor. And, most importantly, make sure that your class works as a team and optimizes their solution skills. It is safe to say that there is one component that is familiar with all of your students, and that is the joystick. The joystick is found in all kinds of game controllers or remote control units, like this one for a drone. You can ask your students if they know how the joystick works. I guess that although this is so well known, few of them will be able to explain the working principle. You can use the whiteboard to show them that a joystick is nothing more than a combination of two potentiometers and, mostly at least, a push button. One potmeter will show values of the x-axis and the other potmeter will show the value of the y-axis. Combining these two movements and corresponding values, for instance, remote control car or plane can be navigated. That's it for the theory. Let's see what we need for our project. Well, we need the following components: the large breadboard with the Pico installed and the pin-out reference card, the stepper motor controller, the joystick and its button, the box of jumper cables and wires, and the cardboard Ferris wheel. Before we dive into the project, we first explain to our class what a Ferris wheel is. The first Ferris wheel was designed by George Washington Gale Ferris Jr., an American engineer, and was erected for the World's Columbian Exposition of 1893 in Chicago. It was 70 meters high. According to the Guinness Book of World Records, the largest Ferris wheel in the world stands in Dubai and it is 250 meters high. Since we covered the basics of the stepper motor in our Arduino lessons, building this project will be a walk in the park for your students. Give them a couple of minutes to put the components together and remind them to work as a team. This is how the finished project looks like. And now we can start with the programming. Well, we are here in our Thonny programming environment, and the first thing that we can do is we can add some comments. For instance, we can say that this file is called steppermotor.py, and we can also say, for instance, that this is lesson number 7, and it is as part of the Educomondo series of MicroPython programming. As long as you are using a hashtag, it is a comment, and you can write all kinds of information that will make the reader of your program more aware of all the different steps that you have been doing. And the best programs really include a lot of hashtags, a lot of comments, so that people really understand the reasoning behind your programming. So the first thing we want to do is, of course, we are going to include a number of libraries. So from machine, we will import both the pin and the ADC. And from time, we are going to import sleep, because we will need some delays. The joystick has an X and a Y axis. But in this exercise, we are only going to use one, and why not use the y-axis? So y-axis equals ADC 26, because we are going to read the analog value from that pin, from that ADC pin. From our Arduino course, you probably still remember the stepper motor and how the stepper motor works. As you know, it has 4 different junctions, 4 different connections, and we will call those connections in 1. And we are going to connect those connectors to one of the pins on our Raspberry Pi Pico. So IN1 equals pin, and we will use the first pin, number 14, and it is a pin out. I'm going to copy paste this 4 times. It's going to make our life a lot easier. So IN2 will be 15, IN3 will be 16, and IN4 will be 17. And if you look at the Pico, you will see that these are the pins that are nicely located at the bottom of the Pico. Okay, in this exercise, we are also going to work with arrays. And the first array that we are going to create is the array pins. And it's actually an array that consists out of what we have just defined. So the first is IN1, IN2, IN3, and IN4. So that's the first array that we are going to use. And we are also going to use another array that is going to define the sequence of zeros and ones that we are going to send to those pins 14 till 17. And let's call the array sequence. And the sequence is, we will start with 1, 0, 0, 0. That's the first thing that we will send to the pin. The second one, what am I doing? That's not correct. Yes. It's 0, 1, 0, 0. Then it's going to be 0, 0, 1, 0. And I think you already got what I'm trying to do here. So these are the on and offs that I'm going to send to the different pins connected to the stepper motor. Okay. Now we can create a loop, and it's going to be an infinite loop, so it's a while true loop. And what will happen in the while true? Well, the first thing that we want to do is, of course, capture the value of the ADC pin. So y value equals the y-axis dot read underscore u16 open and close the rounded brackets. And because we want to monitor those values showing up on the REPL, I'm going to use a simple print command, print y value. And here I'm also going to include a short sleep, because otherwise you may end up with an error message, and it's 0.1. Okay. So what we are trying to do here is to ensure that if we are pushing the y value all the way to the maximum, it is going to go into one direction. The Ferris wheel is going to go in one direction. If I'm pulling back on the joystick, it's actually going to decline the value under a certain threshold, and once that threshold is achieved, it's actually going to go into the other direction. So the stepper motor will go into the opposite direction. So you already hear it, we will need two if statements, two if conditions. And the first one, if the y value is going to be larger than 65,000, and I'm just using 65,000 because that's very close to the maximum of the reading of the 65,535. And what do we want to do if that value or if that condition is met? Well, then we are going to have for loops, and I'm going to introduce here the function step for step in the array sequence that we have just combined, that we have just identified. And what will happen if we and what do we want to do in that step in sequence? Well, another for j, a new variable, in the range of the length of the array pins, the pins j will get the value of step j. And we will need a sleep of, let's say, 1/100th of a second. So let's think a little bit about what we have just typed here. So for step in sequence, and step is a function, it does what it says, it steps into the array sequence step by step. And then we create a new variable, and that variable will be in a range. And what is that range? Well, that range is based on the length of our pins, and pins is an array. And what does it have? It has 4 different elements. So the length is 4. So j can have consecutive the value from 1, 2, 3, 4. Now the pins, so pins 1, the first position in the array, so IN1, will get the value of the first in step, so which is going to be 1. So it's going to get, pin 1 will get the value of 1 that is in the sequence. Once it's done, it go to 2, 3, 4, and so on. And it will end up with a short sleep, just to make sure that the system can cope with the speed of the program. So that's a bit of the nice programming that we have in mind here. And the same will happen if the y value is smaller than 500. What will happen then? Well, we will need the same for loops, so for step in sequence for the variable j in the range of the length of the array pins. And what will happen? So again, pins first position, or position that is defined by j, and we'll get the value of step, but this time I'm going to say it is minus j, because we want to make the motor turn the other way around. Okay, and then we will end again with a sleep of 0.01. Let's see if it works. And as you can see, when I turn it on one side, I push the joystick one side, it actually goes close to 300, 304, 320. And then it gradually increases again, and now I'm going to put the other way, and it goes all the way to the maximum. And let us have a look at how it transfers into our motor. And yes, you can see quite nicely that the stepper motor goes in one direction, and when I push the joystick the other side, it is going into the other direction. If for some of your groups it doesn't work, well, no panic. Let them do some logical fault finding. Were there any error messages in the REPL of Thonny? Did they select the right Raspberry and comms port? Are all the components connected to the correct GPIOs? Are there any loose wires or legs? Or one of those groups just got unlucky and they picked a broken component. That's it for lesson number 7. I hope you and your class enjoyed it. In our lesson number 8, we are going to take the classroom to the outside and build a portable weather station based on a temperature and a humidity sensor and an LCD display. Looking forward to welcoming you again, and bye-bye for now.